Good afternoon, everybody. Today we are discussing the next topic of the nuclear chemistry, that is the group displacement law. The group displacement law was first proposed by the SODI in 1930. So we are discussed yesterday as an alpha emission, beta emission and gamma emission, and what are the changes occurs when an alpha emission occurs and beta emission occurs and gamma emission occurs. So according to the SODI, we can determine the position of the parent and daughter element after the radioactive changes in the periodic table. That means we can determine the position of the parent nuclei, and after the radioactivity we can also determine the position of the daughter element in the periodic table. That is the advantage of the group displacement law. So, according to this concept, when an alpha particle is emitted by a parent nuclei, the newly formed element, that is the daughter nuclei, lie in the group 2 place to the left of the parent element in the periodic table, and while the beta particle is emitted, the new element, that is the daughter nuclei formed, lie in the group 1 place to the right of the parent element. So I have quoted one of the example here. Here the parent nuclei, that is the uranium, emit alpha particle, and we will get thorium as the daughter nuclei. So uranium having the atomic number 92, after emitting alpha particle, we will get a daughter element having the atomic number 2 less than that of the parent nuclei. So the atomic number of the thorium is 90, and mass number is reduced by the 4. And the thorium will emit the beta particle, and we will get the protactinium as the daughter nuclei. So after emitting beta particle, the newly generated the daughter nuclei, that is Pa, protactinium, which is placed in one place right to the parent nuclei thorium, and thorium is located in the 2 place left to the parent nuclei uranium. This is the concept which is introduced by the SODI. And one more concept. In order to determine the total number of the alpha particle which is emitted by the parent nuclei can be determined by an equation, that is change in the mass number of the parent and daughter nuclei divided by 4. So we will get the total number of the alpha particle which is emitted by the parent nuclei. Now we are moving into the one of the example we just discussed earlier, that is the uranium. See here, the uranium having the atomic number 92 will emit alpha particle, and we will get the thorium as the daughter nuclei having the atomic number 90. So according to the group displacement law, the newly generated daughter nuclei, that is the thorium, is located 2 place left to the periodic table. And this thorium emit the beta particle, and the product or daughter nuclei formed after beta emission is the protactinium, which is placed 1 place right to the parent nuclei thorium having the atomic number 91, that is 1 greater than that of the parent nuclei thorium. This is the concept which is introduced by the SODI, and there is one more example which is quoted in your textbook, that is the polonium having the atomic number 84. After alpha emission, we will get a daughter nuclei of the lead which is placed 2 place right to the periodic table, that is atomic number 2 less than that of the parent nuclei polonium. So atomic number of the lead is 82, and this lead will emit beta particle, and we will get the thorium the bismuth as the daughter nuclei, which is located one place right to the parent nuclei, that is lead, having the atomic number 83. This is the concept which is introduced by the Soddy. Now we are moving into the one of the problem. How many alpha and beta particles are emitted in the conversion of the neptunium, atomic number 93 and the mass number is 237, to bismuth, atomic number 83 and the mass number is 209? This is the question. So before we discussing the question, first of all we listen that what is the changes occurs in the chemical reaction, that is the neptunium converted into bismuth, that is the change. And first of all we have to find out the total decrease in mass number of the parent and daughter nuclei. So here it is given the atomic number of the parent nuclei, that is neptunium, is 237 minus the atomic number of the daughter nuclei, that is bismuth, that is 209. So the difference between 237 minus 209 is 28. Then we have studied the total number of the alpha particle emitted by a parent nuclei is calculated by an equation, that is change in mass number of the parent to daughter nuclei divided by 4. Here it is, the difference is 28 divided by 4. So we will get the 7 as the answer. So the 7 alpha particle is emitted by the parent nuclei. Now we have to find out the total number of the beta particle emitted by the parent nuclei. So before that we have to remember that if the parent nuclei emit 7 alpha particle, the total difference in the atomic number is 14. That is 7 into 2, that is equal to 14. So the total decrease in the atomic number of the daughter nuclei after alpha emission is the difference is 14. Difference must be 14, but here it is only 10. So from that we have to understand that we have to find out the actual decrease in the parent nuclei after the 7 alpha particle emission, that is 14, minus the actual difference which is shown by the question, that is 10. So 14 minus 10, that's equal to 4. So the total number of the beta particle emitted is the 4. This is the problem. So this type of the problem is very important in the university question, and similarly the statement, the group displacement law is also important. Thank you.